Okay, welcome to the first lesson for Honors Math 3 here in 2020 to 2021. You should be familiar with most of this stuff here. We are using the Math 3 packet for the first about 3 units. We will be doing some other stuff besides. Okay, so we're doing worksheet 1 today in the packet. Okay, parent functions and also some interval notation. Okay, linear functions, y equals mx, and so you guys should be, like these are the parent functions, so the most basic functions. You're used to seeing y equals mx plus b, but m is the slope where it's delta y over delta x. So let's just do an example here. Y equals -3/5 x, so the slope is -3/5. So if we're doing, x comma y, I don't expect that you have to do this, but if you plug in a 0 for the x, you get y as 0 as well. So y equals mx goes through the origin every time. Okay, using the slope, it's negative. Now, it could be -3 over +5. You could think of it that way, or you could think of it as +3 over -5, but only one of them is negative. Okay, so down 3 over 5. But you could have also done up 3 and left 5. 1, 2, 3, 4, 5. Just realize, that's possible. And it's linear, so, linear. And so, by the way, what's the domain and the range? The domain, left and right, it goes forever left and right. So all reals, and the range, it goes up and down forever as well. So all reals. Okay, special cases. We got horizontal lines and vertical lines. Horizontal lines are in the form of y equals some number, and vertical lines are in the form x equals some number. So y equals -3. 1, 2, 3, horizontal line. Technically, the slope is 0. X equals 2. 1, 2. Now, vertical lines are not a function. The slope is undefined or no slope. Okay, the slope over here on y equals -3 is 0. Okay, moving on. The quadratic functions, parabolas, y equals ax squared. If the a is positive, it's a parabola opening up. If the a is negative, it's a parabola opening down. Y equals -3x squared. So right now, we haven't shifted anything. If I plug in a 0 for x, I get 0 for the y. So they go through 0, 0. If I plug in a 1 or a -1, 1 squared times -3, -1 squared times -3, and so now this is kind of a quick shortcut thing. Parabolas, and you can't do it like a slope. It's not linear, it's a curve. But if you go 1 point to either side of the vertex, the a value tells you how much to go up or go down. So it's -3, so down 3. And then it's a curve. Okay. Domain goes forever left and right. All reals. The range, it's going down forever, which is y is less than or equal to 0. Okay, y equals 1/4 x squared. Well, vertex is at 0, 0. Now this one's opening up because the a is positive. Okay, now remember 1/4, this is not a slope. You cannot do a slope. If I go 1 point to either side, I'd be going up 1/4. Okay, to get more precise, you just got to be kind of careful about what points you actually plug in. So for example, if I plug in a 2, I can see that 2 squared is 4 and 1/4 times 4, so 2, 1 and negative 2, 1. So the closer the a value gets to 0, the wider it gets. The bigger the absolute value of the a is, the narrower it gets. The further away it gets from 0, the narrower it gets. Okay, linear absolute value. Okay, this might be a little bit new to you. It's very similar to a parabola, but it is linear. It's a V shape. Y equals a absolute value of x. If it's positive, it's opening up. If it's negative, it's opening down. It has a vertex. Y equals 2/3 x. Vertex is at 0. Now, because this one is linear, you can actually do it like a slope. So 2/3, so you got up 2 over 3, but it is a V shape, and so if I go up 2 and over 3, then I go up 2 and the other side 3. Now that's not really the way it works, but for today, that's all I'm giving you. So I've got this piece over here, and I've got this piece over here. Try to draw them straight. Exponential functions. You guys should already be familiar with this. In this unit, the a is going to be 1, so we're not even going to rewrite the a. So y equals b to the x. If b is greater than 1, it's this basic shape. And by the way, they always go through 0, 1 and unless we shift them. And if the b is between 0 and 1, then it's this shape. Okay, y equals 3 to the negative x. Now this is kind of a tricky one because that's y equals 1 over 3 to the x, which is really y equals 1/3 to the x. So that's this particular case right here. So if I plug in 0, 1/3 to the 0 is 1. Remember, any number to the 0 power is 1. We need to talk about why that's true. I don't know if I have time right now, but we will talk about why that's true. If I do to the first, 1/3 to the first is 1/3. If I do 1/3 to the negative 1, well, 1/3 to the negative 1 would be 3. And so we sketch it. Okay, and there is a horizontal asymptote at y equals 0 out there. Okay, writing the equation given the graph. Okay, number 8, that is a linear absolute value. So just start with the basics here. Y equals a absolute x. What else do I know about it? It's opening down. What else do I know about it? Well, this point 4, negative 1 is on it. Now, anytime you have a point that is on the curve, you have an x and a y that works in the equation. So plug them in. Negative 1 equals a times absolute of 4. What is the absolute value of 4? Obviously, it's 4. So a is negative 1/4. So y equals negative 1/4 absolute value of x. That's your equation. Okay, now probably when you get these linear absolute value graphs, you might be able to write the equation without showing any work. Curves, you need to show work. When it's linear, you might be able to just kind of count it and figure out what the a value is or what the slope is. But curves, you got to plug in the points. So, for example, here, this point that's highlighted is -3, 4. And we've got y equals ax squared. So I'm going to plug in x and y. 4 equals a times -3 squared. -3 squared is 9. So a is positive 4/9, which matches up because it's opening up. So y equals 4/9 x squared. Okay, number 10. It's an exponential function. Okay, all we got to do is figure out what the b is. Now, the 0, 1 point, it's not helpful, but it's good to see where it is. But it's not helpful in having us figure out what the b is. The 3, 64, those are the points that we're going to use. So 64 equals b to the 3rd. Okay, now has to work out. It has to work out nicely. What number to the 3rd power is 64? Well, isn't 4 to the 3rd 64? Okay, so b is 4, so y equals 4 to the x. Make sure your 4's look like 4's and your y's look like y's. Okay, finally, identify the domain and range for each function. Okay, so now I was talking about interval notation earlier, and this is where we want to use interval notation. So interval notation, parentheses means you cannot touch this point. And it could be an open parenthesis or a closed parenthesis. A bracket means you can touch the point, so it can equal that point. Okay, let's talk domain here first. Number 11. So, by the way, hollow dot means you can't touch the point. Arrows mean that it continues on. And if it doesn't have an arrow, that means it's just starting right there. Okay, so I can touch that point. What is that point? 1, 2, 3, 4, 5, -5. So I can touch -5. And as I go to the left, try to not get mixed up with the range right now. As I go from -5 to -3, I can't touch -3. Okay? Now, but as soon as I get past the -3, then I got some more values in my domain. So I'm going to do a little hookup thing here. The U for union. It's like addition, but it's not really addition. But I'm going to pick up just on the other side of -3, and then it goes to the right forever. Now, what's the biggest number as we go out to the right forever? Well, there is no such thing as a biggest number. So it's going to positive infinity. And infinity is not an actual number, it's a symbol, so we can't actually touch infinity, so we use a parenthesis. Okay, now, it is positive infinity, but as long as it's positive infinity, you don't have to put a plus in front of it. If there's no plus in front of it, we understand that it's positive infinity. Okay, let's talk about the domain for number 12. Okay, so again, left to right. So, oh my goodness, I realize that my domain here is going to be the exact same thing. I can touch at -5, I can't touch at -3. Sorry, I did not mean for them to be the exact same thing. And then, oh, it's not exactly the same because it goes from -3 to x equals 2. I can't touch at 2, and then it goes to the right forever. So not exactly the same thing. There's our domains. Remember, parenthesis means you can't touch it, square bracket means you can touch it. Okay, there are the domains. Let's talk about range. Range are the y values that go up and down. Okay, so what's my highest elevation? 3. Can I touch it? Yes. What's my lowest elevation? Well, technically, see how the arrow, it goes forever and it's going down, so it goes down forever. So the lowest elevation is negative infinity. I can't touch an infinity. So, and then it goes up to, now it doesn't touch elevation -1 right here, but it does touch elevation -1 over here. So we did touch elevation -1, so technically nothing's left out of the range, and we go all the way up to elevation 3, and then that's the highest value. We always want to go from the lowest value to the highest value. Range on this one, okay, so my lowest elevation is -2. Can I touch it? No. Now it goes up forever because notice the arrow going up. Goes up forever, so it's going to infinity. Now it didn't touch elevation 3 over here, but the arrow's going up forever, and so therefore elevation 3 is in there, and so it just goes up forever. Okay, this is kind of brand new stuff. We'll get better at it. You'll get very good at it. Okay, do worksheet 1.